Hi, welcome to day 14. I hope we can do this one fast because I want to get it done fast and I'd rather not get it done slow. Disk fragmentation. Suddenly a scheduled job activates the system's disk defragmenter. Were the situation different, you might sit and watch it for a while, but today you don't have that kind of time. Good. Going fast. Soaking up valuable system resources that are needed elsewhere. The only option is to help it finish the task as soon as possible. Disk in question consists of a 128 by 128 grid. Each square of the grid is either free or used. In this disk, the state of the grid is tracked by the bits in a sequence of NOT hashes. Total of 128 NOT hashes are calculated, each corresponding to a single row in the grid. Each hash contains 128 bits, which correspond to individual grid squares. Each bit of a hash indicates whether that square is free or used. The hash inputs are a key string, a dash, and a number corresponding to the row. If a key string were flurgerja, the first row will be given by the bits of the NOT hash of flurgerja. The second row from the bits of the NOT hash of flurgerja1. The output of a NOT hash is traditionally represented by 32 hexadecimal digits. Each of these digits correspond to 4 bits, for a total of 128 bits. To convert to each bit, turn its hexadecimal digit to its equivalent binary value. High bit first, 0 becomes that. So that continues the process. The first 8 rows appear as follows, using pound to denote used squares and period to denote free ones. Given your actual key string, how many squares are used? Okay, so I didn't really understand that, but I did understand that from day 10 we constructed a NOT hash. So, and I think I have a init.py so I can import things. So, day 14 grid.py. Still have hope that we can do this fast, and that this is one of those where they're just trying to confuse us. Import NOT hash, putting a lot of words around something that's not really that complicated. So let's just try and work through their example. So their example is flurgink. So let's say test input equals flurgink. And then a dash and then a number. So key string with flurgink, the first row, each output. So def rows, and what are we calling this? Key string. Key is a string, and this is going to be a list of I'm going to punt on this type right now because I don't know what I want it to be. And so what I want to say is for I in range 128, I think is what they said. So, you know, and what do we want to call this? The bits of the NOT hash of, so let's say, what do I want to call this? S equals key, so use an F string and then I, so that's, I don't know why I called it S, I just, it's a bad name, and print NOT hash of S. Okay, and then let's just say rows of test input. And so let's just run this, and it's doing a lot of stuff. So it's saying that the first one is D4F7. And let's see if they do that. Bits of the NOT hash. And so we need to convert hex to bits. So let's write that function. Def hex to bits. Hex is a string. And hex is, I think, a reserved word. So we'll call it hexes. And this will also be a string, I think, of zeros and ones. We'll see if I might want to change this to a list of ints, but for now I'm just going to do its and let's just Google Python hex to binary. There must be an easy way to do this, right? import bin. So let's do assert len of hexes equals 32. And this is why it's good to know all your libraries. Bin ASCII. Bits equals bin ASCII dot and unhexlify. Unhexlify hexes. And then we said that should be 128 bits. So assert len bits equals 128 and return bits. And let's write so let's do this. Assert that, oh, well, that's not going to work because it's not long enough. Import bin ASCII dot unhexlify of this thing, odd length string. And that doesn't look at all like what I want. Is it just let's see about this 0x 0x int. No, that didn't work. And let me get rid of that 0x then and just say, so that is that, and then binary of that, and then we want to, what is zfill? That doesn't even work. And we want to do 2. So that seems pretty good. Bits equals bin of int of hexes 16 2. And let's try that. So now let's go back. Each state of Grus chapter bits is with not hashes. Each hash inputs are key string. The output of not hash is traditionally represented. To convert to bits, each hexagonal decimal becomes its bit first. 0 becomes 000. 1 becomes 001, and so on. Continuing this process, the first 8 rows and columns appear as follows. So in this example, 8108 squares are used across the entire. So I think all we want to do is count the zeros. So hashed equals not hashed s. Well, let's just count ones, which is a key, which is a string, and it's just going to give us an int. So let's do this as follows. For I in range 128, do that is hashed. Let's ones equals 0. Hashed equals not hash s. Bits equals hex 2 bits of hashed. Ones plus equal to len bit for bit in bits if bit equals 1, return 1s. So now let's print count 1s of the test input, and I'm not even sure I understood the from correctly, but we'll try it. Def count 1s. Assertion error. Okay. So let's try this. Print hexes, print bits, and print len hexes, hexes, print len bits, bits, and let's try it. So what happens? What happens is the D is 1101, but the 5 is 101, and then 0101. So we need to add leading zeros. Let's see if there's a quick way to do this in Python. Pad left. That sounds like a joke, a JavaScript joke. Nicest way to pad zeros to a string. Zfill. Well, why did zfill not work? Oh, that did work. Okay. So let's do .zfill 128. And now let's try it again. And it says 8108. Is that what they said the right answer was? That is what they said the right answer was. Okay, good. So it would be hard to get that wrong if I had done something wrong. So let's just assert count one's test input equals 8108. That's actually a slow test, but that's okay. If name equals main, key equals that, print count one's key. So let's run it. 8214. So let's try 8214. That is the right answer. Okay. Now, all the defragmenter needs to know is the number of regions. A region is a group of U-squares that are all adjacent, not including diagonals. Every U-square is in exactly one region. Lone U-squares form their own isolated regions, while several adjacent squares all count as a single region. The example above, the following 9 regions are visible, each marked with a distinct digit. Of particular interest is the region marked 8. While it does not appear continuous in the small view, all the squares marked 8 are connected when considering the whole grid. In this example, 1, 2, 4, 2 regions are present. How many regions are present given your key string? Okay, good. So this was actually an interview question that I got asked once. But first what I want to do is I want to make a grid, and it will be given a key, which is a string, and it's going to be a list of zeros and ones. And so we're basically going to say grid list of and so I'm basically recreating all the work that I did, but instead of counting things, I'm just going to actually make them into a grid of zeros and ones. And you know what, I can just leave them as strings. That's fine. That'll be easier than converting them. So what I want to do is I want to say for I in range 128. Again, there's a lot of code duplication here. There's a lot of code duplication here. That's fine. But what we'll say is, so bits here is going to be a string, so I'll just say grid.append list bits, and then return grid. So let me print the grid of the key and just see what happens when I do that. And list is not defined. From typing import lists. Grid is not defined. because it's called make grid. And let's just make sure that and let's just say grid equals make grid key, print grid 0, 10. So that'll be easy enough, and then we can just see what that grid looks like. So it's like sorry, I want to do for a second. I want to do this on test input so I can look at it. 110 1101 0100. Okay, good. So that's fine. And now what I want to do is I want to count the regions. And it's grid, which is a list of string. And so how am I going to count regions? This is a very common interview question. So what I want to do is I basically want to find a 1, and then basically set all of it to 0. Num regions equals 0. And so what I want to do is I want to do, for row, and let me, for I row in enumerate grid, and then for j character in enumerate row. And we're going to destroy the grid here. So why don't I just do from copy import deep copy, and so that I can do grid equals deep copy of the grid. So because I'm going to be destroying it, so I'll destroy copy instead. If the character is 1, then we've found a region, and we want to say num regions plus equals 1, and then we also want to say destroy the region of the grid at I and j. Okay? And then at the end we want to return the number of regions. So every time I find a 1 somewhere, I'm going to say, this is it, and I'm going to destroy a region. And how do I destroy a region? F destroy region grid I and j, and let me give these type ints, list of int, I is an int and j is an int, and I think this is just going to return none. And so what I'm going to say is num rows equals len grid, num calls equals, I know these are both 128, so I could just do 128, but that's fine. And so what I want to say is if I is less than 0, or I is bigger than num rows, or j is less than 0, or j is bigger than num calls. So off the grid, so return, and then otherwise I'm going to check elif grid I j equals 0. So that means that not part of a region, so return. And then otherwise, yes, part of a region, set to 0, and visit the neighbors. And I need to make sure that diagonals aren't included here, but I don't think diagonals are included because basically, yeah, so this 2 is not part of the same region as 5. So I'll say grid I j equals 0, and then what I want to say is destroy region grid I plus 1 j, and let me just copy this 4 times. and then I minus 1j, so we'll just get the 4 neighbors. I j plus 1, and I j minus 1. So that will basically, so what is this going to do? It's going to say, all right, in count regions, just like go one at a time, and now find this one, and then we'll say destroy that, so it'll set it to 0, and then it'll also go to all of its neighbors. It only has 2 neighbors, so it'll go to this guy and do the same thing, then it'll go to this guy, and then at some point we'll be done. So now we'll go back to the other one, and there's a little bit of extra work here, but it's not too bad. So let me comment this out and just print num print count regions of test input and see if that works. And we are expecting 1242. So let's run that. Expected an indented block. What row is that? Line 47. Elif. Oh, I did not type the return here. Okay, good. Let's try this again. 0. Good. So why did that not work? Because I called count regions on the test input instead of make grid of the test input. So that could be part of the problem. Maximum recursion depth exceeded in comparison. So else if grid. So let's print I j, and then let's do this, print I j c, and then we'll see what it's doing. So it keeps going 1 1 2 1 0 1 1 1 2 1 0 1 1 1 2 1 0 1. And why does it do that? It does that because let's see, destroying ij, print off the grid, print already 0. Otherwise, that's the, okay, never mind, I see the problem. I should have set it to string 0. So I think that's the issue, so I'm going to just get rid of all these print statements. And list index out of range. Print ij, and let's see where we've gone awry. Destroying 2 128s, because these should be, I want it to be bigger than or equal to num rows and bigger than or equal to num calls, because if there's 128 rows, then the biggest one is 127. So 1242, and they're saying 1242, so that's good, and I can get rid of that destroying thing. And now let's print count regions of grid. And now let's run it. And 1093 it says. So, and let me change this to an assert count regions make grid test input equals 1242. And now it's saying 1093, so let's call it 1093 and submit it, and that's the right answer. Okay, good. So As has been the case on many of these days, that was a problem that I actually already knew how to solve, which is good. And like I said, I actually got asked that in a job interview once, and I solved it then too. So anyway, that's today. It worked out, no big problem. Find me on Twitter at Joel Grus. Thanks for watching. Keep watching, so I'm going to keep doing these until the 25th, and then I will, I don't know what I'll do after that. I'll miss my live coding, that's for sure.